Some animals are running from predators that no longer exist. They carry armor nothing alive can penetrate, perform defensive formations against threats that went extinct 10,000 years ago, and sprint at speeds that no living predator on their continent can come close to matching. Biologists call these ghost adaptations, evolutionary responses to predators that are gone, but whose shadow is still written into the DNA, the behavior, and the body of the prey they left behind. These are 6 animals that evolved to avoid extinct predators. Starting at number 6 is the Galapagos tortoise, an animal that carries on its back a mystery that Charles Darwin noticed in the 1830s, and that evolutionary biologists have been arguing about ever since. Why do some Galapagos tortoises have saddle-backed shells? The Galapagos archipelago is home to multiple species and subspecies of giant tortoise, and they come in 2 distinct shell shapes. Dome-shaped, which is the classic rounded tortoise silhouette, and saddle-backed, in which the front of the shell rises dramatically upward like a Spanish saddle, creating a high arch over the neck that allows the tortoise to extend its head and neck much farther upward and forward than a dome-shelled tortoise can. The dome-shelled tortoises tend to live on the higher, wetter islands where ground-level vegetation is abundant and there is no need to reach upward for food. The saddle-backed tortoises tend to live on the lower, drier islands where food is scarcer, and the ability to reach higher vegetation, cactus pads, elevated branches, provides a survival advantage. That much is well established. But the upward arch of the saddle-backed shell does something else that has nothing to do with feeding. It allows the tortoise to rear up to its full height and present a larger, taller profile, which is a defensive posture that makes sense only if there was once something on those islands that the tortoise needed to look bigger to deter. The Galapagos Islands today have no native large predators capable of threatening an adult giant tortoise. There are hawks, but hawks do not attack animals that weigh 400 pounds. There are introduced species, rats, dogs, pigs, but these arrived with humans and did not shape the tortoise's evolution over the hundreds of thousands of years it took for the saddle-backed shell to develop. The predator that likely shaped the saddle-backed shell is gone, and its identity remains debated. Some researchers believe it was a now extinct species of giant hawk or eagle, large raptors capable of attacking juvenile tortoises whose shells had not yet fully hardened. Others point to evidence of a large, extinct Galapagos crocodilian that may have shared the island's coastal and freshwater habitats with the tortoises during an earlier geological period. The fossil record on the islands is frustratingly sparse, and the identity of the predator may never be conclusively established, but the shell itself is not debated. It is a defensive structure whose morphology exceeds what feeding ecology alone can explain. Worn by an animal that is still, hundreds of thousands of years later, dressed for a fight that will never come, against an enemy it has never met, carrying the evidence of a threat that exists now only in the shape of its own body. Number 5 is the American bison, the largest land animal in North America, and an animal whose massive body size, explosive herd stampedes, and ferocious defensive aggression are calibrated to a roster of Pleistocene predators so formidable that the wolves and grizzly bears that trouble bison today would have been mid-tier threats at best in the world the bison actually evolved for. During the Pleistocene, bison shared the Great Plains with the American lion, Panthera atrox, a cat that was roughly 25% larger than a modern African lion, and that hunted in what is believed to have been a cooperative or semi-cooperative fashion, the giant short-faced bear, Arctodus simus, which stood over 6 feet tall at the shoulder on all fours, could reach 11 feet standing upright, and was built for sustained pursuit rather than ambush, and the dire wolf, which hunted in large packs with a bite force significantly exceeding the modern gray wolves. Against this predator guild, the bison's adaptations make perfect sense. Its body is enormous. Mature bulls weigh up to 2,000 pounds. Not because modern wolves require prey to be that large to survive encounters with them, but because an American lion or a short-faced bear required a body massive enough to absorb an attack and muscular enough to fight back. The bison's skull is reinforced with a dense, bony plate beneath the forehead that allows it to use its head as a battering ram. a feature that is effective against wolves but wildly over-engineered for a 140-pound canid, and makes far more sense as a defense against a 700-pound cat or a 2,000-pound bear. Bison herds also stampede with an explosive, coordinated violence that is their most dramatic behavioral adaptation. A wall of animals moving at 35 miles per hour that flattens anything in its path, and this response is triggered with a speed and an intensity that exceeds what modern predators typically provoke. A wolf pack approaching a bison herd today often finds the herd already moving before the wolves have committed to an attack. Because the bison's threat detection threshold is set not to the danger level of wolves, but to the danger level of something much larger, much faster, and much more capable of killing an adult in open terrain. A bison ecologist who spent over 15 years studying herd dynamics on the northern plains described the stampede as a nuclear response to a conventional threat, noting that the energy expenditure, the risk of injury from the stampede itself, and the sheer scale of the response were disproportionate to the predation pressure modern wolves actually exert, and that the bison was still running its defensive playbook against a starting lineup that had been off the field for 12,000 years. At number 4 is the muskox, a stocky, shaggy, horned bovid that lives in the Arctic tundra of Canada, Greenland, and Alaska, and that performs one of the most iconic and most tragically outdated defensive behaviors in the animal kingdom. A behavior that was brilliant against the predators it was designed for, and that is now, in a brutal evolutionary irony, one of the things most likely to get it killed. When threatened, musk oxen form a defensive circle, adults facing outward with their massive curved horns presented in a continuous, unbroken wall of bone and muscle, calves tucked safely in the center. And they hold this formation with a discipline and a cohesion that reflects thousands of generations of intense selective pressure for exactly this response. The circle was devastatingly effective against the predators of the Pleistocene: dire wolves, cave lions, the North American short-faced bear, and the other large, powerful pack-hunting carnivores that shared the Arctic and subarctic landscape with musk oxen during the last ice age. A pack of dire wolves confronting a circle of adult musk oxen had no viable angle of attack. The horns formed an impenetrable perimeter. The calves were unreachable in the center. No individual could be isolated without the attacking wolf exposing itself to a horn strike capable of crushing ribs and puncturing organs. The defense worked so well that musk oxen survived the mass extinctions of the late Pleistocene that wiped out most of the megafauna around them. Mammoths, mastodons, giant ground sloths, and the very predators that the circle was designed to defeat. The defense won the war. And then the world changed. The Pleistocene predators went extinct. The wolves that remained were smaller, less powerful, and less specialized than their Pleistocene ancestors. And humans arrived with rifles. Modern wolves can sometimes harass a muskox circle long enough to cause the formation to break, at which point the scattered individuals become vulnerable to the kind of pursuit predation that the circle was specifically designed to prevent. And a muskox herd that forms a defensive circle in response to a human with a rifle has just arranged itself into a stationary, tightly grouped, broadside target at close range, which is why muskoxen were hunted nearly to extinction across much of their historical range before conservation protections were implemented. The muskox's circle is a masterpiece of cooperative defense, arguably one of the most effective anti-predator strategies ever evolved by any herd animal. It is also a relic, a flawless solution to a problem that no longer exists, performed with perfect fidelity every time a threat appears, by an animal that cannot know that the rules of the world it evolved in changed 12,000 years ago and never changed back. If you're enjoying this countdown, you can get early access to all Loving Feral videos over on our Spotify channel. The link is in the description. Number 3 is the kangaroo. And the kangaroo's extraordinary speed, its powerful hind legs, and its ability to deliver bone-breaking defensive kicks were not shaped primarily by the dingoes and wedge-tailed eagles that are its main predators today. They were shaped by predators that were larger, faster, more heavily armed, and more terrifying than anything currently alive in Australia. Predators that have been extinct for roughly 40,000 years, but whose influence is still legible in every aspect of the kangaroo's anatomy. The kangaroo evolved alongside Thylacoleo, the marsupial lion, a heavily built, approximately 250-pound predator, with the most powerful bite force relative to body size of any mammal that has ever lived, and a set of retractable bolt cutter-like premolars designed to shear through bone, tendon, and flesh with a mechanical efficiency that no modern Australian predator can approach. The kangaroo also shared its landscape with Megalania, a giant monitor lizard that reached lengths of up to 18 feet and weights exceeding 1,000 pounds. Essentially a Komodo dragon scaled up to the dimensions of a saltwater crocodile and equipped with the same ambush hunting strategy and the same toxic bite. Against these predators, the kangaroo's adaptations are not just proportionate, they are precisely calibrated. Its powerful hind legs can propel it at sustained speeds exceeding 35 miles per hour in open flight, far faster than any current Australian predator requires, and far faster than a dingo can sustain. Its defensive kick, delivered with heavily clawed hind feet while the kangaroo balances on its muscular tail, can disembowel a dog, shatter ribs, and open deep lacerations in an attacker's abdomen, which is an extraordinary amount of weaponry for an herbivore whose current terrestrial predator is a 40-pound canid. Large male kangaroos also engage in a defensive grappling behavior when cornered, seizing an attacker with their forelimbs and attempting to rake it with their hindclaws, a strategy that is effective against dogs, but that is wildly over-engineered for a dingo and makes far more sense as a close-quarters defense against a 250-pound marsupial lion that attacked by leaping onto its prey and biting down with those massive shearing premolars. The kangaroo is also an excellent swimmer and will flee into water when pursued, a behavior that provides limited tactical advantage against dingoes, which swim competently, but that would have been highly effective against Thylacoleo, a terrestrial ambush predator with no known aquatic capability. Every major defensive feature of the kangaroo, its speed, its kick, its grappling, its flight into water, is tuned to a frequency that does not match any living predator on the continent. The kangaroo's body is a museum of Pleistocene defense, and every exhibit in it is labeled with the name of something that died 40,000 years ago. Number 2 is the African elephant, the largest land animal on Earth and an animal whose sheer size, aggressive herd defense, and extraordinarily extended calf development period are, according to a growing body of paleontological and behavioral research, at least partially the product of an arms race with predators that went extinct between 10,000 and 1.5 million years ago. Predators that were capable of doing something that no living predator can do, which is kill a young elephant despite the protection of a herd of adults. Today, an adult African elephant has no natural predators. Lions occasionally take calves in a few specialized populations, but successful lion predation on elephants is rare, risky for the pride, and limited to unusual circumstances. An adult elephant is, for all practical purposes, invulnerable to predation. And yet elephant herds defend their calves with a ferocity, a coordination, and a willingness to risk injury that seems wildly disproportionate to the actual threat posed by a few lions. Adults form protective rings. Matriarchs charge aggressors with lethal intent. And the collective defense is maintained with a sustained intensity that suggests the elephants are calibrated to a threat level that modern lions simply do not represent. The predators that did represent that threat level were the saber-toothed cats, Homotherium and Meganterion in Africa, and their relatives across Eurasia, large, powerfully built, often pack-hunting felids with elongated canine teeth specifically adapted to puncture the thick hides of megaherbivores and reach the major blood vessels beneath. Saber-toothed cats were elephant specialists. Their dental morphology is consistent with targeting large, thick-skinned prey. Their skeletal structure suggests cooperative hunting, and the fossil sites where their remains are found alongside juvenile mammoth and mastodon bones tell a story of a predator-prey relationship that lasted millions of years and exerted intense selective pressure on elephant behavior, social structure, and reproductive strategy. The herd defense, the aggressive matriarchal charges, the protective circle around calves, the willingness of non-related adults to risk their own safety to protect another female's offspring makes perfect evolutionary sense as a response to a predator that was large enough, fast enough, and cooperative enough to isolate and kill a calf if the herd's defense was anything less than total. The extended calf dependency period. Young elephants stay with their mothers and within the protective herd for years longer than nutritional weaning requires, also makes sense as an adaptation to a predator that specifically targeted juveniles and that could be deterred only by the continuous presence of multiple armed adults. The saber-toothed cats have been gone for 10,000 years. The elephants still defend as though they are coming. A paleontologist who studied the coevolution of proboscideans and saber-toothed predators described the elephant's herd defense as a battle formation for a war that ended 10,000 years ago, noting that the intensity of the response, the speed of the mobilization, and the willingness of adult elephants to sustain injury or death to protect a calf are not calibrated to lions. They are calibrated to something that was much more dangerous, much more persistent, and much better at killing elephants than anything left alive today, and that the elephants will continue defending against it for as long as elephants exist. Because evolution does not decommission defenses when the threat is removed. It simply leaves them running, forever, against an enemy that is no longer there. And at number 1, the animal that most dramatically, most measurably, and most famously evolved to avoid an extinct predator is the pronghorn antelope, the second fastest land animal on Earth, capable of sustaining speeds of 55 miles per hour across open ground for miles at a stretch. And an animal that carries in its legs, its lungs, its heart, and its blood the answer to a question that has puzzled biologists for decades. Why is the pronghorn so absurdly, unnecessarily, almost comically fast? The fastest predator in North America today is the gray wolf, which tops out at about 35 to 40 miles per hour in short bursts. The coyote is slower. The mountain lion is an ambush predator that does not chase prey in the open. There is nothing alive on the continent that requires the pronghorn to run at 55 miles per hour. And there is certainly nothing that requires it to sustain that speed for 4 to 6 miles, which the pronghorn can do thanks to an oversized trachea, lungs 3 times the size of a comparably sized goat's, a heart proportionally larger than any other North American mammals, and blood with an unusually high oxygen-carrying capacity that delivers fuel to the muscles at a rate that no other land animal of similar size can match. The pronghorn is not built for the predators it has now. It is built for a predator that has been extinct for roughly 12,000 years, the American cheetah, Myricynonyx trumani, a long-legged, lightly built, high-speed pursuit predator that occupied the same open plains the pronghorn occupies today, and that hunted with the same chase-down and catch strategy that the modern African cheetah uses in the Serengeti. The American cheetah was fast, likely capable of speeds approaching 60 to 65 miles per hour based on skeletal analysis, and it hunted in an environment where the only viable escape strategy was to outrun it, because the open, flat, treeless plains of Pleistocene North America offered no cover, no climbing options, and no hiding places. The only pronghorns that survived were the ones that were faster than the cheetah, and the only way to be faster than the cheetah was to be faster than anything that had ever chased them, generation after generation, for millions of years, until the pronghorn's cardiovascular system, its musculature, and its skeletal architecture were honed to a level of performance so extreme that it exceeded the predator's capability by a margin that guaranteed survival. And then the American cheetah went extinct at the end of the last ice age, along with the short-faced bear, the dire wolf, the American lion, and most of the other Pleistocene megafauna that had shaped the pronghorn's evolution. The predator died. The speed remained. And every time a pronghorn explodes across a Wyoming prairie at 55 miles per hour, leaving every living predator on the continent in its dust without breaking stride, it is running from a ghost, a long-legged cat that died 12,000 years ago, and that lives on only in the body of the animal it spent millions of years trying to catch. A wildlife biologist who spent 2 decades studying pronghorn ecology described watching a herd sprint across open grassland as watching an animal outrun its own history, and noted that the pronghorn's speed is not just a biological curiosity or an evolutionary leftover. It is a memorial, written in muscle and bone and breath, to a predator that shaped it, chased it, defined it, and ultimately lost the race so completely that it vanished from the earth while the animal it was chasing kept running, and has not stopped since. If you made it this far, thank you for watching. You can get early access to upcoming Loving Feral videos on our Spotify channel. The link is in the description. If you enjoyed this one, feel free to like, subscribe, or share it with someone who appreciates the idea that evolution remembers things long after the world has forgotten them. See you in the next one.